All right, chemistry students, especially those of you at home, this is the remediation for particles in motion test. I'm going to go through about 7 different questions. These notes are also posted on Google Classroom, so you can follow along if you've printed out those notes. This first question I'm going to look at is probably the one that was done the worst. We have a box that is at 25 degrees Celsius, and by the way, every one of these questions is going to be slightly different from the one in the test, but it's going to be the same kind of question. So if there's some math, the numbers will have been changed, but you should, after listening to this video, know how to do these questions. So that box has got a temperature of 25 degrees Celsius, and it's got a pressure of 1 atmosphere. And they say there's a piston that's free to move. In the test, it didn't actually talk about a piston, but it just still spoke about the volume. So the question says that it's asking which box represents the volume at 0 degrees Celsius and 1 atmosphere. So 0 degrees Celsius means that your temperature is going from 25 degrees to 0 degrees Celsius. We know that when volume goes down, or when temperature goes down, volume goes down. So the box we're going to choose is going to have a smaller volume than what we started with. All of them, though, have got a smaller volume. So we've got to ask ourselves, how much lower did the temperature go? And we've got to think of it in terms of Kelvin. So let's put this in Kelvin. It's 298, changing to standard temperature, which is 273 Kelvin. And when it does that, we know volume is going to go down. So let's just give this box a volume of 10. Okay, let's say 10 liters. And let's set up a fraction with these two numbers. It's going to be a regular fraction, 273 over 298. When we multiply that by 10, so 273 divided by 298 times by 10, we basically get 9.1, or just 9 if we want to round it properly. So we start with 10 and we go to 9 liters. There's just a small decrease in volume. So you've got to ask yourself, which of these containers show a small decrease in volume? In your test, the temperature goes from 25 to 5 degrees, I think. So it's even a smaller change in temperature. So there's even a smaller change in volume. So that should be pretty easy to figure out. The next one is a math problem. It's mainly my first period had a problem with that, but if you're on second or fourth period, you could still watch this to figure out how to do the problem. So I'm going to fill the information in as I read it. Due to friction between a tire and road surface, the temperature of air inside a tire increases as one drives. If the tire pressure is 35 psi, when the car's in the driveway at 6 degrees Celsius, 6 degrees Celsius we're going to put in Kelvin, so that's going to be 279. What is the temperature of the air inside the tire in degrees Celsius? So when the pressure gets to 41. So what is the temperature inside the tire when the pressure gets to 41? So our final pressure is going to be 41. The temperature is what we want to work out. The volume of the tire, they're saying, is constant. Okay, and the amount of gas in the tire is constant. So we can see here pressure's going up, and we know temperature goes up because they're telling us with pressure. So since we want the temperature to increase, we're going to create a fraction that is going to have the bigger number on top, because an improper fraction has got a value of greater than 1. So 41 over 35 multiplied by 279. 41 divided by 35 times by 41 divided by 35 times by 279 equals 382. So we have a temperature of 382 Kelvin. What makes this problem difficult, though, or a bit more tricky, is they say, what is the temperature in Celsius? We had to convert to Kelvin to do the math, but now we've got to go back to Celsius. So we are just going to subtract 273. So 382 minus 273 is going to give us our proper temperature in Celsius. So 382 minus 273, and we get 109. So 109 degrees Celsius. The numbers in the test are different, but this is how you work this problem. All right, the next one. It says the pressure of a 250 milliliter sample of gas. So we've got 250 for our volume. Is 85 kilopascals. So that's our pressure, 85. What would be the pressure if the volume was increased to 475 milliliters? Assume temperature is constant. They don't talk about the amount of gas either, so we can also assume that is constant. So now let's look at the effect. Volume, you can see, is increasing. It's going up. We know pressure and volume are inversely related. If volume goes up, pressure goes down. And so the fraction we are going to create with the 250 and the 475 is going to have a value of less than 1. It's a regular fraction. Because when we multiply it by 85, that 85 is going to change to a smaller number. So we're going to say 250 divided by 475 multiplied by 85, and we get 44.73. We need to use our significant figures rule, so 47.3 something is just actually going to be 47. So it's going to be 47 kilopascals. The next one, and this one quite a few students struggled with. There's 3 variables in this one. So the amount of gas is constant. I'm just jumping to that part over there. It says a sample of gas occupies 711 milliliters, that's our volume, at 24 degrees Celsius. 24 degrees Celsius we want to put into Kelvin, so we're going to add 273. So that's going to be 297. Our pressure is 996 millimeters. Find the volume of gas at STP. So we want volume, that's our X, at standard temperature and pressure. So let's look at the reference table. And on the first page, we can see our standard temperature is either 0 or 273, but we're going to choose 273. Now the pressure, we're going to choose millimeters of mercury as our standard pressure because they gave us pressure in millimeters of mercury. So we're going to use 760, and it's a 760 with a decimal point. So 760, our temperature is going to be 273. I'm going to switch colors here just so we can keep track of what's going on. So pressure is going down. When pressure goes down, we know volume goes up. So the fraction I create with these two numbers has to be a fraction that's going to make my volume go up. So it's going to be an improper fraction. I'm going to set it up now. 996 divided by 760. Now let's look at our temperature. Temperature is going down. We know that when temperature goes down, volume goes down. All the relationships between the other variables are going to be direct relationships, except for pressure and volume. So temperature is going down, volume is going down. The fraction I need to create is going to be a regular fraction. So it's going to be 273 over 297. And we're going to multiply that by 711. And we're going to get our final answer. I'm not actually going to work this one out. You can do the math to figure out, but you're just going to say 996 over 760 multiplied by 273 over 297 multiplied by 711. And that is going to give you your volume. And I don't know at this point if it's going to go up or going to go down. The math is going to give you your final answer. Let's look at the next one. If the volume of an air pump used to inflate a football decreases from 780 to 275, so we'll put 780 there as our initial volume, 275 as our final, and the original pressure was 82.5, what is the new pressure? So we want our final pressure. Assume temperature stays constant. They don't talk about the amount of gas changing, so let's assume that's constant as well. So look at volume. Volume is going from 780 to 275. That's an ugly 7 there. 780 to 275. Volume is going down, but pressure is inversely related to volume. Volume goes down, pressure goes up. The fraction I need to create with these two numbers has to be an improper fraction, because only an improper fraction is going to make my number go up. So 780 over 275 times by 82.5. Let's get that. I'll work this one up. 780 divided by, oh, forgot what it was. 780 divided by 275 times by 82.5, and we get 234. But 234 has actually got three significant figures. 780 is going to limit us to two significant figures. So 234, if we round it, is going to change to 230. That's our final answer. So it's going to be 230 kilopascals. In the test, you've got the same problem but with different numbers, and this is how you work it. The next problem, mainly my second period struggled with this one, but first and fourth, you guys can listen as well if you're at home. So a tank of compressed gas has a maximum safe pressure limit of 960. It'll be logical to make that our final pressure. So 960 is the maximum it can take. The pressure gauge reads 320 when the temperature is 30. 30 degrees, I can't use that in the math. I've got to actually convert that to Kelvin. So add 273, it's going to be 303. What is the highest temperature in degrees Celsius that the tank can withstand? So volume is not changing because it's going to explode before it gets bigger, and then the amount of gas is not changing. Look at pressure. Pressure is going up. What is going to happen to temperature is also going to go up. So the question is saying, what is the temperature going to be when that pressure goes up to 960? So we're going to create an improper fraction, 960 over 320. It's improper because we want to see how much the temperature is going to go up, not go down. So 960 divided by, and I forgot what the other temperature was. 960 divided by 320. So 960 divided by 320 multiplied by 303 gives us 909. But that's 909 Kelvin. Now there might be an answer in the test that is 909, or it'll be a different answer, but it'll be Kelvin. This question says, what is the temperature in degrees Celsius? So we've got to go back to Celsius. So we're going to say 909 minus 273. Minus 273 equals 636. But we still need to use our rules for significant figures. 320 has only got two significant figures. And so we are going to round 636 to 640. Because of the 6, we're going to round up. So it's 640 degrees Celsius. All right, the last one is one where we're going to use the ideal gas law. Calculate the volume of 3.2 moles of gas at a temperature of minus 17 degrees Celsius and a pressure of 250. We don't have initial and final conditions here, so we don't work it the same way we've worked the other problems. We've got fixed conditions, we've got three different variables, and we've got to find a fourth one, so we're going to use the ideal gas equation, which is in your reference table. PV equals nRT. Let's write it down. PV equals nRT. Calculate the volume. I'm going to go ahead and change the color of volume just so we can emphasize that that's what we want to find out. Calculate the volume of 3.2 moles of gas. So and at minus 17 and 250. So pressure is 250. The volume, we're going to keep it as V because it's our unknown. We're trying to work it out. The amount of gas is our N. It's 3.2 moles. Now, R can have 3 different values. And it's going to be based on what we're measuring pressure in. Our pressure is in kilopascals. So let's choose the correct value for R. On the very first page of your reference table, reference tables, here's our R's. You can see there are 3 different values, 0.0821, 62.4, okay, and 8.314. We're going to use the 8.314 because we're working in kilopascals. Okay, so that's the one we're going to use. So 3.2 times 8.314, and then we're going to multiply that by our temperature, which is minus 17, and we're going to have to add that to 273. So I can say 273 minus 17, or we could say minus 17 plus 273. Either way, we're going to get 256 as our temperature. And so the hardest part is done. We just got to work the problem now. So the 3.2, the 8.314, all of those numbers are going to be multiplied by each other. And then you immediately are going to divide by the 250. Because we want to isolate the V. So we've got to get rid of the 250. So we would have divided by 250 on the left. Whatever you do to the one side, you do to the other. So on the right-hand side, we're going to divide by 250. And that's how you work the problem. You get your answer, and that will be your volume. And volume is always going to be in liters when you're using this equation. You guys work it out yourself, but that's the same way you're going to do it when you do the test. I hope this helps. Let me know if you've got any other questions.